This series of notes, and it's called reaction stoichiometry. So reaction stoichiometry, and this is going to be part 1. All right, so to start off this set of notes, I want to give you guys the best definition of stoichiometry that I can. Okay? So stoichiometry. Stoichiometry is a relationship between the quantity of substances that take part in a chemical reaction. They are typically whole integer ratios. The most important word in here is ratios and relationship. That's the biggest takeaway. Okay. The best way I can explain this to you is to use food to do that, because everyone has a common language for food. We all have to eat some way or shape or form to be alive. We all have to ingest food, okay? So it's something we all have in common. So I'm going to use food to explain this. So we're going to use food as an example. How many of you have ever made a sandwich in your life? Great. How many of you have ever made pancakes? Great. Little did you know, you actually were performing a stoichiometric problem when you did either of those two things. So I'm going to give you guys an example. We're going to use pancakes because that is my favorite breakfast food. So we have 8 pancakes. Can be made from 1 cup of mix, 3/4 cup of milk, and 1 egg. My question to you, how many eggs do I need to make 24 pancakes? Take a second and think about that question. So stoichiometry is similar. We use balanced chemical equations instead of recipes. Okay. So if I gave you a recipe to make cookies and I said you need flour, you need sugar, you need eggs, you need milk, you need vanilla, you need salt, and you need baking soda, would you be able to make those cookies? Why? I didn't tell you the quantities. I just said this is what you need. That's why a balanced chemical equation is so important. It tells you specifically how much you need, and it's going to tell you how much you make and how much you need in order to make that amount. Does that make sense? So a recipe for cookies tells you you need this many cups of this, you need this many tablespoons of this, you need this number of eggs. And it usually tells you we'll make around 24 cookies, or we'll make, usually that's what a recipe tells you. So balanced chemical equations do the same thing. They tell us how much we need, and they usually tell us how much we make. All right. I want you guys to write a number 1, and under it or near it, write mole to mole. Okay. This is our first set of equations or set of practice problems we're going to do. And to make it easy for you guys to go back when you're studying, mole to mole be a good indicator for you to be able to find this. Okay, so mole to mole. 7, if you want to wrap around one of the different sides of your table, you can. Huh? No. Okay, I'm saying it might just make it easier for you. So our first thing that we're going to look at is mole to mole. And specifically, we're going to be looking at our coefficients in our chemical equations. We call these coefficients stoichiometric factors. Another thing that I call them are mole ratios. For those of you who watched the Ed puzzle last week, so basically all of you guys who are home, you watch an Ed puzzle on mole ratios. So that was kind of a dip your toe in to what we're learning today. All right. So I'm going to give us an example of a balanced chemical equation. So this is one we use very commonly. We have nitrogen gas plus hydrogen gas gives us ammonia gas. Coefficients, in case you didn't know, are the number in front. Okay. So what if I asked you, what is my ratio of NH3 to H2? What is my ratio of NH3 to H2? Could you answer that just from looking at this? Not 2 to 3. Or sorry, yes, 2 to 3. I'm so sorry, Jesus. Your ratio would be 2 to 3. Okay? Because we have a 2 in front of NH3 and a 3 in front of H2. Another way that you could write this is 2 moles of NH3 over 3 moles of H2. Does it help if it's up higher? Okay. We can use this information to help us do some calculations. So we can use this to help us calculate the number of moles of NH3 made from a given number of moles of H2, or vice versa. And there is an equation that we can use that's going to help us with that. So I'm going to go ahead and write this equation down. You're going to want to as well, and you're maybe going to want to star it or circle it, highlight it, something to draw your eyes to this equation when you're looking at your notes. Okay? So the equation is going to be your given number of moles and the upper left hand of our train tracks. And then on the right side of our train tracks, we're going to have our want coefficient over our given coefficient. And that's going to give us our wanted number of moles. So let's look at an example problem. So our example problem, how many moles of H2 are needed to make 4 moles of NH3? I'm going to write the equation down here again so that we have it. So our equation is N2 plus 3H2 gives us 2NH3. In one of these instances, the equation would be given to you. Okay, so that equation would be given to you. It's not something that you would have to come up with in your own head. That equation would be given to you. What is my given in this problem? Four moles of NH3. Very good. My given is 4 moles of NH3. What do I want? What am I searching for? Of moles of H2. I'm searching for moles of H2. That is my want. So I'm going to take my given, which is 4 moles of NH3. That's going to go in my upper left corner of my train track. I need to find my wanted coefficient. So my want is moles of H2. So I'm going to look for H2 in my balanced equation. So not there, but H2 is right here. So H2, and the coefficient is 3. So we have 3 mole of H2. We're supposed to put that over our given coefficient. So my given is NH3. So I'm going to find NH3 in this balanced chemical equation. And I'm going to write down the coefficient in front of that, which is 2. And we would write mole NH3. Moles of NH3 then cancel out. And that leaves us with 4 times 3 divided by 2, which gives us an answer of 6 moles of H2. Okay, so I've got 2 practice problems for you. We're going to start with with the first one, and then I'll write down the second one. So practice problem. How many moles of I2 are needed to react with 0.429 moles of aluminum? Your equation is 2Al plus 3I2 gives us 2AlI3. Something I want you to make a note of, or something I want you to definitely pay attention to, is anytime you're given an equation, always check that it's balanced before you begin, because if it's not balanced, you're not going to get the right answer. So a really quick and easy way to check is to just count in your head. 2 aluminum, 2 aluminum. 6I, 6I. This one's balanced and good to go. So I'm going to give you guys a few seconds or a few moments to go ahead and give this one a shot, and then we will work through it together. All right. So for this one, what is my want? What do I want? Moles of I2. Okay. What is my given? Very good. 0.429 moles of aluminum. So we can start to set up our train tracks. Our 0.429 moles of aluminum goes in the upper left. Next, we need to figure out our coefficients. So it's very important that you are specifically looking for the correct thing. So you would look for I2, not I3, okay? Or you'd look for AL, not AL I3. Does that make sense? So we're specifically looking for those two things, not them with a combination of something else, okay? So I2, we've got right here. AL, we've got right there. So what you guys should have written down is 2AL on the bottom and 3 I2 moles or 3 moles of I2 on top. Your moles of aluminum cancel out, and you should have ended up with 0.644-ish moles of I2, or 0.64. Is that what we got? Awesome. All right, second practice problem, and it's going to be our last one for the day. How many moles of CaOH2 are needed to react with 1.36 mole H3PO4? I promise the next time we do these notes, your problems will be written out for you. So it's not like you're going to have to write your practice problems like we are today. Your chemical equation. Go ahead and give this one a try. Remember to check if it's balanced. What you should have ended up with is 1.36 mole of H3PO4 in your given slot. Then you should have multiplied it times 3 mole of CaOH2 and over 2 mole H3PO4. That way your moles of H3PO4 cancel out, and you eventually would have gotten an answer of 2.04 moles of CaOH2. Sound right? Okay. Friday, we're going to start number 2 on this, still on the same set of notes, but I want you guys to have it written down so you know where to begin Friday. So number 2, which is going to be mole to particle / molecule. So just so you have that for Friday, because that's where we're going to start. Those of you who are at home, I did post the assignment we're going to work on Friday, the classroom. You can begin on it. The only ones you'll be able to do are the odds, because you haven't learned the second part, which is going to be all of the evens on that worksheet. So you can begin the odds. Those of you who are coming into class tomorrow, I do have a paper copy of that worksheet for you. So if you would like the paper copy, you can hold off and wait for tomorrow. You don't have to work on this yet. We're going to be working on it all day Friday, and it's not due till Monday. Okay? Any questions, comments, or concerns? What's that?
You said the last due Monday?